So now in this video, we will study the concurrency condition. So what is the concurrency condition? So if there are more lines, 3 or more lines, then we say that they are concurrent if they all pass through a single point. For example, this is a line, this is another line, and this is another line. But they are not passing through a single point, so we will say that they are not concurrent. So how the 3 lines will be concurrent? If the third line, whatever its direction is, but it must have passed through this point. For example, if I pass the third line from here, now we can say that these 3 lines are concurrent. You can pass the third line in any direction, but it should pass through the same point at which the remaining 2 lines are intersecting. So if all of the lines are intersecting at the same point, then we will say that the system is concurrent. So in this system, we will assume that there are more lines and less variables. So let's look at the theorem. The theorem says for a system of m lines in n variables, and for example, the system is defined by the m different equations. So for the first equation, I can write a11 x1, a12 x2 up to so on, a1n xn. Because there are n variables, so I have written x1, x2 up to xn. So I have written n variables. Similarly, I will write other equations. Okay, dot dot dot. So at the end, I will write the last equations. Since there are m lines, so I will write m equations. So mth equation will be am1 x1 up to so on amn xn is equal to bm. So these are m equations and n variables. But note that in this system, our m is always bigger than n. So if m is bigger than n, that means there are more equations and less variables. Then these lines are concurrent if the following are wholes. The first one is any n by n subsystem has the same solution. Okay, so if you take any n by n system, it must have the same solution. And the second condition is that the solution satisfies all the remaining equations. So if any of these two conditions are satisfied, we will say that the system is concurrent. Now here is the straight way to solve the problem of the concurrency. So to test for the concurrency, we have the following steps. The first one is to select any n equations. Since there are n variables and more equations, so you have to select n equations. I mean those many equations such that as many you have variables. So the next step is to solve those equations by any of the method which are described here. The first one is Cramer's rule, matrix inversion method, and the Gaussian elimination methods. We have studied all of the methods, so you can use any of the method to solve the system of n linear equations. So once you solve the system of n linear equations, which are actually sublinear equations, you have to verify the rest of the equations. You have to verify the solution for the rest of the equations. Okay, because from the first n equations you will get some solution. So that solution must be verified for the other equations which were not picked in these n equations. Now we will have an example and we will solve it. In this example, we have to find m, which makes the given line to be concurrent. These are the given concurrent lines. We have to find m. Okay, here is the solution. So since you can check, there are only two variables and there are three equations. So there are more equations and one less variables. So first of all, you have to choose any two equations. So for simplicity, we can choose the first two equations. So after choosing the first two equations, we will solve them. Okay, so from the first equations, you can separate x. If you separate x, then this term will go to the this side. So you will get x is equal to 1 minus 1 minus my. Now you will put this value of x into the second line. So if you put it into the second line, you will get 2 times x plus 6y is equal to minus m. But in place of x, you get the value of x which you have got from here. Now if you multiply 2 inside, you will get this value, and after more simplification, you will get this. Okay, because if you take y common from these two values and take these two to the other side, you will get this value. And then if you divide this term to the other side, you will get y is equal to this value. Okay, so we have got the value of y. Now if you put the value of y in place of x in this equation, you will get the in place of y in this equation, you will get the value of x. Okay, so this is the equation in which we can put the value of y here in this place. So if you put, and after simplification, you will get this, and after more simplification, you will get the value of x. So these are the simple calculations. And now we have to check whether the system is concurrent or not. Since we are given that the system is concurrent, so we have to find the value of m. So that means the values of x and y which we have found, they must satisfy the third equation. Okay, so we will plug these values of x and y into the third equation. This is the third equation. So I have plugged m as it is, 9 as it is, 4 as it is. Now I will plug the value of x and the value of y here. Since I have already found the values, the value of x is this, the value of y is this. So after multiplication m in inside, I will get this minus 6m plus m cube. Plus, if you multiply 9 inside, you will get this is equal to 4. If you take LCM, 6 minus 2m, because this is common in both, and if you add the numerators of both, you will get this value, and after more simplification, you will get this, and after adding these two terms, you will get this value. Okay, now if you take this to the other side, you will because this is in the denominator, if you take to the other side, it will multiply with 4, and if you multiply 4 inside, you will get this value, and after taking all of the values to the left hand side, you will get this value, and after simplification, you will get m cube minus 7m minus 6. Now this is cubic equation. We don't know how to solve it, but in order to solve it, we have to guess the first solution. So if you check whether m is equal to 1 satisfies it or not. So m is equal to 1 will not satisfy this equation. So let's check m is equal to 0. M is equal to 0 will also not satisfy. If you plug m is equal to minus 1, it will satisfy this equation, because if you plug m is equal to minus 1 here, m is equal to minus 1 here, and calculate, you will end up with 0. Here is the verification. Okay, if you plug every value, every m by minus 1, you will end up with 0. So that means m is equal to minus 1 is satisfying this equation. So we have found the first root. So if we have found the first root, then we can find the other roots as well by using the synthetic division. So what is the synthetic division? In order to find the synthetic division, we will first find the coefficients. So the coefficient of m cube is 1. So I have written 1 here. Then the coefficient of m square is 0, because there is no m square. So I will write 0. Then the coefficient of m is minus 7. So I will plug minus 7 here. Then the constant term is minus 6. So I will plug minus 6 here. Okay. Then what is the initial root? Initial root is m is equal to minus 1, which we have obtained by a guess. So I will write that initial root here, and I will take the first value as it is. The first value as it is 1, and then I will multiply this 1 with this minus 1. So I will get minus 1. So I will put it here. Okay. Now if I add these two values, I will get minus 1. Now the turn for minus 1 is to multiply with minus 1. I will get plus 1, because minus 1 times minus 1 is plus 1. So I will write plus 1 here. And now if I add these two values, I will get negative 6. If I multiply this negative 6 with this value, I will get plus 6. So I will write plus 6 here. And if I add these two values, I will get 0. So if you have done this thing correctly, you will always end up with 0. Now, since we have reduced one variable, so this is the constant, this is the coefficient of m, this is the coefficient of m square. So I can write m square minus m minus 6, okay? Because this is the coefficient of m square, this is the coefficient of m, and this is the constant term. So we have reduced the variables. We have reduced the power of the variable. So now we can solve this equation by any of the method. We have three methods. The first one is by factorization, the other one is by formula, the third one is by completing square. So I will do it by factorization. So if I do multiplication of this one and this minus 6, so I will end up with minus 6. Okay, so I have to factor minus 6 such that I get this factor minus 1. So how to factor minus 6? Since we know that 3 times 2 is 6, but I need minus 6, so one of them should be negative. So which one should be negative? If I write this minus, then 3 minus 2 is plus 1, but here I have minus 1. So this is not negative, so I need to put this negative, because negative 3 plus 2 is minus 1, which is exactly this coefficient. So I will write minus 3m plus 2m, okay, instead of this m. Okay, so the next step is m square as it is, and instead of this m I have written negative 3m plus 2m. Okay, and this 6 is as it is. Now if I take m common from the first two terms, then here I will get m, and here I will get minus 3. And if I take 2 common from the second two terms, then here I will get m, and here I will get minus 3, because 2 is common. 2 3 times 6, so I will write m minus 3. Now you can check in this term and in this term m minus 3 is common. So I will take m minus 3 as a common factor, and here I will end up with m, and here I will end up with 2. So I will write m plus 2. Now since the product of these two terms is 0, so I will put the first term to be 0 and the second term to be 0. From here I can take this 3 to this side, I will get m is equal to 3, and from here I can take this 2 to this side, I will get m is equal to minus 2. So we have three values of m. These are the two values of m, and there is another value which we have supposed in the start. So we have three values, m is equal to minus 1, and m is equal to 3, and m is equal to negative 2. So for these values of m, the lines are concurrent. So in this way, you can always check that the given line are concurrent or not. So what you have to do, you have to select the lines, you have to select as many lines as many you have variables. So for example, if there are n variables, so you have to select n lines from m lines. So what will you do? You will solve those lines and you will get the solutions of those n lines, and then you will put those solutions in the rest of the lines which were not chosen by you. And if the other lines also satisfy those solutions, then you will say that the given lines are concurrent.